Hello and welcome to Microsoft Ignite 2022. My name is Dominic. I'm a developer advocate at MongoDB, and today I'm going to show you what MongoDB is, what Atlas is, and how to use that on Microsoft Azure App Service. Over the next 20 minutes, I'll give you an introduction to MongoDB, our database product Atlas, how to interact with it, and how to deploy and run it on Microsoft Azure App Service. But before we do that, let's look at some of the basics. What actually is MongoDB and Atlas? Most of you will probably be familiar with relational databases like SQL. The data is structured in tables consisting of rows and columns. Each row represents one entry in that table, whereas the columns do identify the parameters of an entry. In the example here, you can see two entries for table users. What if we also wanted to save the phone number for those users? We could add another column for that and save the number right there. This would work just fine as long as every user has only one phone number. But as soon as you need to save two or more phone numbers, you need to come up with a solution on how to save that properly. The very naive approach could be to just save them all in the same entry, maybe divided by commas or something like that. The next best solution would be to just save multiple entries for the same users, one entry per phone number. As you can see right away, this would just lead to duplicated data. To solve this problem, relational databases chose a different approach. You extract the phone number to a new table using one row per entry and then describe a relation between those two tables. So far, this is all clear and easy to understand. So what's the problem with relational databases? And that's what we can see here. When the amount of data and relationships gets bigger, the whole structure becomes very complex. It's not easy to read anymore, and if you want to traverse those relationships to find out which data point in one table belongs to a data point in a different table, you have to do something that is called a join. That means bringing all those tables together into one big joined table that contains all the connected data. Aside from the complexity, there is another very important problem, and that is performance. Joining all those tables and traversing the data gets slower the more tables with relationship you produce. How can we solve that problem? Let's have a look instead at document databases. And one of the core principles of the document database is data that is accessed together gets stored together. As the name suggests, in a document database, the data is saved as a document. In case of MongoDB, this would be a format that is called BSON, which stands for binary JSON. Here's how the two users from the previous example look like if we put them into documents. The keys are name and phone, and as the value you can then flexibly assign whatever data type makes sense to you. So what about the example with the employer earlier, where both users had a relationship to the same entry in the employer table and to the same ID of that? The answer is both documents get their own copy of the same data. You might ask why, especially since we talked about data duplication and extracting data into a different table in SQL earlier. If you think a decade or two back, storage was a lot harder to get your hands on and a lot more expensive. What happens now if you access one of those documents? You don't have to join, check for relationships, traverse the data or anything. It all just exists in one location, and this makes reading the data very, very fast. And let's also look at some of the queries that you can perform on those databases. First of all, just a simple select star from people, which basically gets every single entry from the table people. In Atlas, we would do that by writing db.people.find and pass in the argument empty dictionary. So on the left side, once again, you got select star from people where age equals 25. And now the filter is exactly that. The field is called age, and the value we're looking for is 25. What if I go a little bit further and we'll try to get every entry where the age is greater than 25 and not equal? The filter in that case, once again, has the field age. And then you can pass in a whole new dictionary as a value, which represents what to filter for this field age. In that case, there is one new field, which is called $GT for greater than, and this value is now going to be the 25. Now that we've understood the basics about Atlas, let's now start a new cluster and look at some of the features it offers. You can find our developer data platform Atlas at cloud.mongodb.com. When you create a new Atlas cluster, you have many different options to make sure your needs are met. Shared clusters are a cheap way to get started and familiarize yourself with Atlas. They're dedicated clusters for more performance and even serverless if you prefer that route. The cluster can live in a AWS infrastructure, Google Cloud Platform, or, you guessed it, Microsoft Azure. In all of those, many different locations can be chosen to give you maximum flexibility. The flexibility of Atlas can also be seen in authentication. Several methods are provided, from simple user passwords, password certificates, or, for example, AWS Identity Access Management. As an additional layer of security, you can also add IP filters to make sure your cluster can only be accessed from your systems. One of the great ways to get started with Atlas is to import our sample dataset with collections for movies, apartments, and other familiar data you might know from IMDb, Airbnb, etc. After you've added the sample data or added your own data, you can then start querying directly in the Atlas UI. This is especially useful if you haven't worked with Atlas or non-relational databases in general before. While this is good practice and helpful if you just want to manually check something, we next want to look at how to programmatically access the database and explore the ways to perform CRUD operations on it. One of the ways to access our database are the MongoDB Drivers. They are our SDK provided in several different languages. First, we need to add the .NET package to our project. It's called MongoDB.Driver. And now let's have a look at some code. After we've imported the driver, the first thing we need to do is open a connection to Atlas. The driver provides a class called Mongo Client that will be our main interface for this. We need to create an instance of it and tell it how to get hold of our Atlas cluster. For this, we use a connection string. Let's have a look at Atlas to find out what that actually is. If we go back to the Atlas UI and click on Connect, we'll be presented with several options, and we'll conveniently get a string that includes all the information that we need. More specifically, the username, the password, and of course the cluster we're trying to access. Using the string that is saved here in the environment variable atlas_URI, we can then create the Mongo client instance. As a first step, one of the things we can do, just to get things started, is to get a list of all database names in this cluster. Now that we got a connection to the database, let's look at some CRUD operations using the MongoDB.NET drivers. One of the sample databases that gets created when importing our sample set contains movies. We access with the get database function and then choose which collection to use with get collection. Note that we need to provide a type for this generic function. Since all documents are BSON documents, that's the type we need here. And we can use this generic type to work with it for now. Now that we've got hold of the collection, we can search for a specific movie. The filter we saw in the earlier slide is done using, once again, another BSON document, where we pass in the key and value that we're looking for. All we have to do is call the find function, passing in the filter, and we can print a list of all the matches. Now let's have a look at a filter that's a bit more complicated than just the title. This time we want to filter the field runtime. Additionally, we're going to filter for movies that were released before 1960. And if you want to apply multiple filters, it is as easy as listing every filter as a new document and passing all that together in one single BSON document and then pass it on to the filter. But as you can imagine, this is going to be quite an amount of code if you add multiple filters to this. The drivers offer a very handy way to simplify that a little bit. Using the filter definitions builder, we can create a new filter definition. This builder offers functions that resemble exactly what we've been looking for in the previous example. Greater than and lower than in that case. We just pass in the key and value as two separate parameters and can then use the filter definition that gets created and pass it into the find function. Let's have a look at the data structure of such a movie. There are a lot of different fields in here. One thing to note here is that there is also a field called _ID of type object ID This one is automatically generated by Atlas. Every single document gets one of those to make them uniquely identifiable. What if we want a document though that we don't need all the fields for? The drivers got us covered in that case as well. So let's look at how that works. And we call them projections. So after we filtered a collection, we can now use project and pass in another BSON document to tell the projection which keys or which fields we want to show and which ones we don't want to show. So if you look at the BSON document projection, you'll see that there is title 1, year 1, and plot 1. And those are the three things we want to show. There's one exception to that, and that's the _ID field. The _ID field by default always gets shown. You don't have to list it. You can, however, if you explicitly want to, hide it. And that's the only case where you would pass in a field name and a 0 into the projection. So far, we've only looked at BSON documents when retrying or retrieving data. While you can certainly work with the BSON documents directly, the same way you can work with the dictionaries directly, you would usually prefer to just use the language features instead and map this BSON document to an instance of a class that you've defined ahead of time. And all you need to do is to define your properties and then add some attributes to them. First, BSON ignore extra elements, signals that not every field in the received BSON will also be in this class, and they can be just ignored and don't need to be mapped because we're not interested in them. The first paragraph you see here is ID. There are two things going on here. First, we define this as a BSON ID. Remember when we looked at the BSON document earlier, we saw that there is an _ID field which gets auto-generated by Atlas. Using the attribute BSON ID, we clarify that whatever name we use for the property here should be mapped to this _ID. The other attribute we need is the BSON representation, because the type used in Atlas is object ID, and since this should get mapped to a string here, we need to add the second attribute as well. Note that you can just define the property names in this class to be exactly the same as the fields in the BSON document and just remove all the attributes to clarify how they should be mapped. It would work as well, but it doesn't conform to .NET coding guidelines, so we want to do this mapping here. When we go back to our example, the only thing we need to change is, instead of passing in a BSON document as the generic parameter in get collection or iMongo collection and later on list of movies or list of BSON documents, we now pass in movie. With that, automatically make sure that whichever data we get here gets mapped to the movies class we created. Now, since we're working with proper C# objects, iterating over them to print them is easier, and we can make use of the formatted string compared to just like printing whatever the toString function would do in the previous example. We read some data, but how about actually adding some data entries to the list of movies? As before, we need to get hold of the collection that we want to insert a new element into. Next, we need to actually create the element. And when we're done with this, we use the insert1 function on the collection we want to insert this element into. What if we want to update an element in the database then? For updates, we can use the builders again. We've seen them in an earlier example, and this is how it works. Let's reuse the filter here that we've written earlier to find the movie by a specific title. In the second part, you can see an update definition builder. The way they work is that you pass in the fields or the field that needs to be changed into the set function along with the new value. Now that we've built an update definition, all we need to do is call update1 and use the filter to find the actual document we want to update, and then call update to actually change it. Last but not least, the final one of the 4 CRUD operations is delete. Similar to insert1 and update1, the driver offers a delete1 function on collections. All you have to do is pass in a filter that specifies which element should be deleted. So we need to create a new BSON document again. And in this case, we filter directly by the _ID, and then we can delete said document again. All right, let's switch to the live demo part of today's presentation. I have opened up Visual Studio here and will create a completely new project so you can see how easy it actually is to go through the process of deploying to Microsoft Azure App Service. What I will be using here is a Blazor server app. In case you don't know Blazor, it is an amazing tool also by Microsoft that lets you easily create websites. Let's call this Ignite 2022. Doesn't matter where it's going to get put for now. We're going to use .NET 6.0, leave the rest on default as well, and create the project. One of the nice things here, and that's what we're probably going to use as an example, is the template creates a couple of pages for you. So if I start this project right away, and we're going to see in the output here, it's going to get built, it's going to get started. So this is basically what you're going to get if you choose the Blazor server app template. Perfect. So we got a website ready, don't even have to code anything, which is exactly what we want here, because we don't want to look at the local website. What we want to look at is how do we actually deploy this. So let's stop it for now. All we have to do is to choose our project here and choose publish. We want to deploy to Azure. We do want to deploy an Azure App Service. In that case, we're just going to leave it on Windows. That's going to be fine. If you do have Azure, you have a Azure subscription here already. If not, you would have to do a subscription, which you can also do right here. And then we say, all right, give me the resource group. We will create a Ignite resource. Let's call it Ignite 2022 App Service. As I said before, choose the subscription that is active. As a resource group, just for the sake of it, let's create a new one, Ignite 2022 resource group. And as for the hosting plan, let's also just create a new one. Imagine there's no one here. Ignite 2022 hosting plan. For me, I'm going to choose, let's choose UK West is actually fine. We're going to choose the free one, which is sufficient for the demo, and then create it. So what's going to happen now is the IDE in the background will create a new app service for us. And those are all the settings that we need. There's not really much more to that. All right, and we're already done. So we see our new Ignite 2022 resource group, which contains the Ignite 2022 app service. You can finish this and it's ready. So what you can see up here, we get the option to publish. I'm gonna click that right away to get it started, and you'll see that's gonna happen quite quickly actually. A new build is gonna get started here. The application gets checked if it would actually even run successful when it gets deployed, because otherwise there's no reason to even try to deploy. Which is a great step, so you can quickly get the feedback. Okay, my app is actually fine. It builds, it runs. That's great. The necessary files and folders get all added here to the package that's supposed to be published. You can already see the URL down here that we'll get, which is Ignite 2022 App Service .azurewebsites.net. And as you can see, this is now a properly published and deployed website. So if you would go to Ignite 2022 App Service.azurewebsites.net right now, this is what you're going to see, which is of course just the example that we use with its Ignite 2022 name up here. And that's how easy it actually is to deploy and run a website. It took us, I'd say, not more than 3 minutes right now. And we do have a website out there that we can start putting content on. And if it's just a static website, that's all you need, including the Atlas and the data from Atlas that we've seen before, that I showed you how to access, edit, update using the drivers. Would be not much additional work either. So you're up and running in basically no time, and can focus on what you actually want to do, which is the content of your site, the content of your app. And you don't really have to figure out a lot about how do I access data, how do I persist, take care of all those synchronizations, take care of deploying your app somewhere to actually host it. All this is done for you in the combination of MongoDB and Microsoft together. All right, let's go back to the slides. Here's some notes from MongoDB Atlas and Azure Marketplace. Retire your Azure commitment, consolidate billing through your Azure account, pay as you go with no minimums or upfront commitments, and simplified procurement with just a few clicks. If you have any questions, feel free to reach out to me anytime. Thank you for joining this presentation today. I hope you learned something new, and we'll see you next time. Goodbye.